So project 1 is due today. If you haven't handed it in yet, hand that in. So if we want to calculate this simple enough looking integral, 3x times cosine x dx, u substitution is not going to work, right? Because if you let u be cosine x, then its derivative is sine, and now you're introducing a whole new trig function into the integrand, and the 3x isn't going to cancel. So we have this new technique called integration by parts. Here's the formula. It's the integral of u times dv. So you break your integrand into two pieces, a product of two things, u and dv, both of which are a function of x, right? So here we could let, 3x could be u and cosine x dx could be dv, or switch it. Okay. And if you can write your integrand like that, then the integral is equal to u times v minus the integral of v du. So u and dv are both functions of x. I can derive the formula on the board in a couple of minutes. I think it would be best if we did an example first and then derive it, because it will just be like, okay, now I get what you're talking about. So if we look at 3x cosine x dx, so I need to choose a u and a dv. So I'm going to have u equals v equals du equals dv equals. Okay, so I'm choosing u and dv because that's what the formula sets out. I have to have my integrand written as u times a dv. So these are the things I have to choose. Choose u and choose dv. So for u, because the formula, I have to be able to have a du, so I have to be able to take the derivative of u, and I have to know what v is. So when I choose dv, I have to be able to integrate it. So I'm choosing a u and a dv strategically, knowing I'm going to have to take the derivative of u and the antiderivative of dv. So sort of the best advice I can give is to choose the hardest dv you can, right? The most complicated thing that you can get an antiderivative of. So in this expression, what would you choose as your dv? Cosine x, yeah, the more complicated piece, if you can get its antiderivative. So if I choose dv to be cosine x dx, because the dx is glued to the cosine x there. If I had chosen dv to be the 3x, it would be 3x dx. The dx always goes with the dv part. All right, so then my u is my 3x. And to apply the formula, I have to know what du is, and I have to know what v is. So I'm going to differentiate and integrate to get these two things. All right, so what is the derivative of 3x? 3. So du dx. Du dx is 3, which means du is 3 dx. Does that make sense? I just like multiplied both sides by the dx. And that's where this dx comes from also. This is like dv dx is cosine x, so dv is cosine x dx. All right, so what is my antiderivative, or my integral, of cosine x dx? Sine x. Good. All right, so I've chosen a u, I've chosen a dv, and that allowed me to calculate du and v. And now I'm going to try to apply my formula. Okay, so my integral of u dv is equal to u times v minus integral of v du. And this is my initial problem here, 3x cosine x dx. Okay, so that should be equal to u times v, so 3x times sine x, minus the integral of v times du. So that would be sine x times 3 dx, which is 3 sine x dx. Now the integral has changed into something that I can actually do. This is just the integral of sine x. So this ends up as 3x sine x minus the antiderivative of sine would be negative cosine, so this is going to become plus 3 cosine x plus c. And we should probably check by taking the derivative of this thing that it does come out to 3x cosine x, the original integrand. So let's go ahead and do that. Okay, so I want to take the derivative of this thing. Okay, so the first term, 3x sine x, to take its derivative, I have to use what? Product rule. Okay, so I'm going to have first times the derivative of the second plus the second times the derivative of the first. So there's the product rule. So I get the first term. And then the second term, the derivative of 3 cosine x. The derivative of cosine is negative sine. So this will be minus 3 sine x. And the derivative of the plus c is 0. Those two terms drop out. And you do get 3x cosine x. So you might notice that this was, to take this derivative, I had to use the product rule, right? Integration by parts is kind of the thing that undoes the product rule. So now, if I show you the derivation of integration by parts, I think it will be a little bit clearer. Okay, so start with the product rule. I want to take the product rule of u times v. U and v are both functions of x, and I want to take d dx of u times v. So the product rule says first times the derivative of the second. So the first is u. The derivative of v would be dv dx, plus the second, which is v, times the derivative of the first, which is du dx. All right, so now I'm going to take the integral of both sides. If I integrate both sides with respect to x, what is the integral of the derivative of u times v? U times v. Yeah, the integral and the derivative kind of cancel, and you get uv. U times v is equal to, now think of like distributing this dx here, because you always throw a dx after an integral, and then I'm going to distribute it, so this becomes the integral. The dx's are going to cancel, and this becomes u dv plus the integral of v du. And then you just solve for the integral of u dv. Subtract this integral from both sides. So I have the integral of u times dv is equal to u times v minus the integral of v du. Feels a little bit circular. And it kind of is, because it's just giving us something equivalent to our original integrand that just happens to be a little bit easier to calculate. All right, let's do another one together. So that now I'm trying to take the integral of ln of x dx. And this is a definite integral, which means that my answer is going to be a number or a function? A number. Good. All right, so when you want to apply the fundamental theorem to by parts, you just evaluate the u times v from a to b, and then do the other integral from a to b. So but we'll start by finding the antiderivative. So first, I just want to find the integral of ln x dx. So I have to choose a u and a dv, right? This is my formula, the integral of u times dv. If I can make it, set it up to look like that, I can use this handy formula. So I have to choose a u, and I have to choose a dv. All right, so when I choose u, I have to be able to take its integral, and when I choose dv, I have to be able to, sorry, I said that wrong. When you choose u, you have to be able to take its derivative, right? So I have to choose u, and I have to choose dv. When I choose u, I need to be able to take its derivative. And when I choose dv, I have to be able to take its antiderivative. All right, so what do I have in there that I could choose as u and dv? ln x and 1, yeah. What do you want to make ln x, u or dv? If I made it dv, that means that would imply that I know its antiderivative, in which case I would be done already, right? So I'm going to make u ln x. So my general advice that I gave before was to choose dv as the most complicated thing that you are able to take the antiderivative of, right? We don't know the antiderivative of ln x, so we're going to have that be u. And that leaves the rest, the dx, to be dv. So now you take du. The derivative of ln x is 1 over x. So du dx is 1 over x, which means du is 1 over x dx. And then when I take the integral of both sides of this, the antiderivative of dv is v. What's the antiderivative of dx? X. Okay, so now I can apply my formula, u times v minus the integral of v du. So u times v, that would be ln x times x minus the integral of v times du. V is x, du is 1 over x dx. So x times 1 over x, what is that? Just 1. So this is 1 dx. What's the antiderivative of 1 dx? X. Yeah. So now we found the antiderivative. Now we just have to evaluate from 1 to e. Thank you. So then the integral from 1 to e of ln x dx. So here's step 2. This is my antiderivative, just an antiderivative, which means I can leave off the plus c from 1 to e. So when I plug in e, I get e times the ln of e. What's the ln of e? 1. So this is e times 1 minus e 0. And when I plug in 1, I get 1. What's the ln of 1? 0. So this term is 0. Minus 1 is negative 1. So this should come out to 1. I should write all that out. E ln e minus e minus 1 ln 1 minus 1. That comes out to 0 minus negative 1. Let's check. Okay, so I want to find the area under ln x from 1 to e. So ln of x, window for ln x. If I'm going from 1 to e, maybe I'll go like 0 to 3. And then for y, the ln of 1 is 0, and it's going to go up to the ln of e, which is 1. So maybe I'll go like negative 1 to 2. Oops. All right, that's a good window. So now I'm going to go to second calc, option 7, and put in 1 for my lower bound and E for my upper bound. And the area under there should be 1 if I did it right. And okay, good. All right. Okay so far? Now it's brand new. Okay, so here's a weird one. We're going to have to solve for the original integral here. You'll see what I mean in a second. Okay. So I have e to the 2x times sine x. So this looks kind of like a product, and a u substitution is not going to work because whatever I choose for u, its derivative is going to introduce a brand new function into the integrand that's not going to cancel. So u substitution is not a good choice here. But when you see a product and u substitution won't work, by parts is always sort of the next to go-to thing. So I have to choose a u, and I have to choose a dv. So these two are what I choose, u and dv. Choose dv as the most complicated thing that you can take an antiderivative of. So any ideas? What do you want to try for dv? Sine x, sure. So it's actually sine x dx, yeah. Because dv is just really short for dv dx, right? So dv is sine x dx, like you multiplied the dx to the other side. All right, so that leaves u to be e to the 2x. So now I have to calculate du and v. So du, that's the derivative of e to the 2x, or du dx is the derivative of e to the 2x. So du is called a differential. So du is going to be 2e to the 2x dx. Dx just went from the bottom of the du dx fraction multiplied to the other side. All right, and then v, this would be the integral of sine x dx. So the function whose derivative is sine would be negative cosine. Okay, good. So now I have my u and my dv. I've calculated du and v. I can apply the formula. So I'm just going to start by writing the formula down. The integral of u dv is equal to u times v minus the integral of v du. And in my case, u is e to the 2x and dv is sine x dx. So this is the integral of e to the 2x times sine x dx. Okay. U is e to the 2x. V is negative cosine x, so I'm going to put the negative here, minus the integral of v du. And v is negative cosine x, and du is 2e to the 2x. So I'll just write it all out. Negative cosine x times 2e to 2x dx. And have a little more room. Okay. So I can simplify this integrand a little bit. So the hope when you do by parts is that this new integral that you create will be easier than your original integral. But when I'm looking at this, I'm going, oh my God, that's even more complicated than the original integral. Now I have a negative and a 2, but I can pull those out, right? The negative and the 2. I can pull them right out of the integral. So this is going to be negative e to the 2x cosine x plus 2 times the integral of e to the 2x cosine x dx. So it feels like I have made no progress at all, right? Because e to the 2x cosine x dx is not any simpler than e to the 2x sine x dx. And I still can't do this. Unless I do by parts on this again. But is that going to help? I don't know. I think maybe we should try switching our choice of u and dv. Let's try that. So like u substitution, your choice of u and dv, there are some general guiding principles on how you choose them, but sometimes you have to go back and try something else. They don't always work. So let's see. Okay. So before we chose dv as sine x dx, so let's make that u this time. And dv will be e to the 2x dx. Okay, so that means du is cosine x dx. And v, the antiderivative of e to the 2x, what would that be? Function whose derivative is e to the 2x. E to the 2x over 2, yeah. Because the derivative of e to some stuff, right, e to the 2x would be e to the 2x times 2 because of the chain rule. So you need the 1/2 there to cancel, so the coefficient is 1. And if you wanted to do that more formally, you'd actually would use u substitution. Let u be the 2x. Okay, so let's try this again. So my integral of u dv e to the 2x sine x dx. That's my u, and my dv equals u times v, 1/2 e to the 2x sine x. That's u times v, minus the integral of v du. So this would be 1/2 e to the 2x cosine x dx. What do you think? Thoughts? I could pull the 1/2 out, yeah, and then I'd have the integral of e to the 2x cosine x, which is exactly what I had before, right? E to the 2x cosine x. And I thought I was stuck, but seems no matter, even with the choice of the other v du, v and u and dv, I'm stuck here again. So my only option, if I want to evaluate this integral, is to do by parts again. So let's try. So we have to not forget the big picture, right? Don't forget this whole line. Now I'm just going to take this integral, do some side work to see if I can get an expression for that integral. I'll pull the 1/2 out. So I just am going to do e to the 2x cosine x dx. So by parts says choose a u and choose a dv. Doesn't seem like it's going to matter, right, which one we choose. I might put cosine x here, which means that v would be sine x. And then e to the 2x would be here, and du would be 2 e to the 2x dx. Yeah, it's exactly like we did. Well, it's a different integral, so it's, yeah, we're doing the same approach, but yeah. All right, so this should equal u times v, e to the 2x sine x, minus the integral of v du, which is 2e to the 2x, that's my du, times v, which is sine x. And then I've got a dx. Okay. So this is e to the 2x sine x minus 2 times the integral of e to the 2x sine x dx. We're going in circles, right? This integral of e to the 2x sine x dx is exactly what I started with. That's what I'm trying to figure out. So I feel like I should be frustrated right now, but we can do a sneaky little trick here. Now I'm going to replace this integral with what I just figured it out to be. So I'm going to rewrite my whole line here. This is the integral of e to the 2x sine x dx, and that's what I want to know, right? This equals 1/2 e to the 2x sine x minus 1/2 times that integral. I pulled the 1/2 out, and that integral is the integral of e to the 2x sine x. I got that on the next slide. That was my side work. Calculated this integral and I got this. Okay. I'm tempted to throw up my hands and say I'm going in circles, but I have an equation now. And the thing I want to know shows up in it twice on both sides, once on each side. I've got it here and I've got it here. If you let that thing be, say, y, right, you could just solve for it. So I would add 1/2 times that integral to both sides. Okay, so on the right-hand side, I've still got 1/2 e to the 2x sine x. And over here, I have one integral plus 1/2 of the same integral, which is 3/2 times the integral of e to the 2x sine x dx. And then I could just multiply both sides by 2/3. So I end up knowing that the integral of e to the 2x sine x dx, 1/2 times 2/3 would be 1/3 e to the 2x x, and then throw on the plus c. That's pretty crazy. So we had to do by parts twice and then solve for the integral we wanted. Yeah, Danny? Sure. Yes. Oh my God. Yes. Sorry, I didn't make the full substitution. Yeah. This is what I should have substituted, is this whole thing. You get the method though, right? Okay. We'll go back. I'll go back and fix it. Thank you. That was from the previous. That was my incorrect substitution. When I changed. So this cosine in the next line became a sine. That's because this thing that I circled in blue, I calculated out. I found another expression that's equivalent to it on the next slide. which involves the integral of e to the 2x sine x, right? And I forgot this other part. So it's this whole thing I have to replace that blue square with. So it's e to the 2x sine x. So now I'm going to have to write really small here. Okay. E to the 2x sine x minus the integral of 2e to the 2x sine x dx. So this thing that I circled in blue got replaced with the what's in the pink parentheses. Make those blue so you can see the substitution. Okay, so now we solve for the integral e to the 2x sine x dx. I should spend some time over on the right here simplifying. So this is 1/2 e to the 2x sine x minus 1/2 e to the 2x sine x. So this term and this term are going to go away. And then I distribute my 1/2 over here, and my 1/2 and my 2 are going to cancel. My negative and my negative are going to cancel, and I'm just going to end up with oh no, e to the 2x sine x dx equals, well, obviously, right? It equals itself. So what do you think the problem is? No. The problem is here. I chose a different u in dv than I did in the original substitution. Let's do this again. Actually, you know what? This is a good chance for you to practice a by parts. I'll give you the u and the dv. You gotta switch them from what I did, and you can tell me what it equals. So dv was cosine x. We're going to let that be u. And so dv will be e to the 2x dx. Piece together. All right, so if u is cosine x, du is negative sine x dx. And if dv is e to the 2x dx, its antiderivative would be 1/2 e to the 2x. All right, so now by parts, this is the integral of u times dv. And that should equal u times v, so 1/2 e to the 2x cosine x, u times v, minus the integral of v times du. So this is 1/2 e to the 2x, that's my v, and then du is negative sine x dx, and I'm going to throw the negative right there. Okay. Now, this, e to the 2x sine x dx is exactly the integral I'm looking to solve for. So I can't, just do that. But I can go take what I just put in this blue box and go back to my original problem and replace this blue box with it. That's what it's equal to. Okay, so let's see. It was 1/2 e to the 2x cosine x plus 1/2 the integral of e to the 2x sine x dx. I'm just going to pull that 1/2 out here. 1/2. What? Yeah, because I took this 1/2 and I pulled it out of the integral, so it's right here. Yeah, right. Yeah, sorry, that is I should have, this 1/2 I put over here. And then just evaluated the integral on the next page. Okay, now let's simplify the right side. 1/2 e to the 2x sine x. 1/2 times 1/2 is 1/4. E to the 2x cosine x. 1/2 times 1/2 is 1/4. The integral of e to the 2x sine x dx. And now all of that equals the integral of e to the 2x sine x dx. All right, so I have no like terms to combine on the right-hand side, but I do have a 1/4 times the integral I'm looking for. So I'm going to add that to both sides. Erase this. Okay, so 1 plus 1/4 is 5/4. So that's going to equal 1/2 e to the 2x sine x minus 1/4 e to the 2x cosine x. Then multiply both sides by 4/5. And I should throw a plus C on.
That's a loud thing there, huh?
Yeah, the little things fell out. Yeah. Let's try to think of some way that we could check this. I could take the derivative of the right-hand side, and I should end up with the integrand, right? But taking the derivative of the right-hand, and that would be the best way to check it, right? But taking this derivative involves the product rule twice. It's going to be messy. So something I could do is do a definite integral and just check that it comes out correctly. So if I wanted to say go from 0 to 1, I could plug in a 1, plug in a 0, subtract them, and then have the calculator do it also and make sure you get the same number. But I'm not going to because we're running out of time. Okay. Actually, we have time, I guess. I don't want to. All right, so another great way to check stuff, though, would be Wolfram alpha. Let's try that. If anyone hasn't seen it, very useful. Okay, so I just want to check what is the integral of e to the 2x sine x. So I go to Wolfram alpha and I type that in. And it will give me the definite integral. And then you just have to check and see if yours is equivalent to this one. So we've got e squared times sine x minus x cosine x. So e squared, that makes sense. We're missing an x in there somewhere. So there's a mistake in this somewhere. That looks like it could be equivalent to ours. We might have to do a little bit of algebraic manipulation to show that that's right, but so we've got a 1/5 cosine x and a 2/5 sine x. Yeah, that's going to be 2/5, and that's going to be 1/5. Yeah, it's equivalent when you distribute the 4/5. Hooray! Okay, so I'm sure you guys are like totally psyched to try this on your own now. So go ahead.